According to one estimate, sending 1 kilogram of anything to the moon on a spacecraft would cost $15,000, a consideration weighing on NASA as they ramp up the Artemis program, half a century after the Apollo missions.
Having a permanent base on the moon will be important in order to take that next leap and go into and explore different locations in space.
And growing plants using water and soil we find on the moon will be crucial for our ability to sustain longer duration stays there.
We will live off the land instead of constantly having new food sent up.
So when space biologists recently grew plants in actual moon soil, it was a game changer. Let's find out how they did it. All plants need light, air, water, a source of nutrition, and optimal temperature. But growing plants is different in space.
It's a hostile environment. You don't have an atmosphere. You don't have the elements that help us and plants and animals thrive.
No oxygen, no CO2, and until some years ago, we thought no water.
We now know that there is water on the moon. Part of the Artemis program will see how much water we can mine to grow plants. There are big temperature fluxes between a lunar day and a lunar night. There could be almost a 300 degrees Celsius swing in temperatures. There is no atmosphere, and also there is no protective magnetic shell around the moon, the way we have a protective magnetic shell around Earth called the Van Allen belt. And so what happens is ionizing particles that are coming from solar wind or from galactic cosmic radiation bombard the surface of the moon. There are also micrometeorites that are bombarding the surface. That is what is called space weathering.
Not to be confused with the type of weather or erosion we have on Earth.
We have rivers and we have wind, and these cause erosion, and it will often make those jagged rocks much more gentle. They'll round off the edges, whereas we don't have the benefit of that kind of erosion on the surface of the moon.
This constant bombardment with cosmic rays and pelting with space rocks basically makes the moon soil toxic to plants.
Even though the composition of the actual regolith has many of the same elements that we have on Earth. It's rich in iron and silicon and potassium and manganese and magnesium, but how it reacts to biological materials can be different. Because of these impacts, rock particles can reform into what is called agglutinates, and they can trap in them some of these metals, which can, in fact, be harmful to plants.
It's so different, it's not even called soil, it's called regolith, because technically soil has beneficial organic material like microbes, insects, or decaying plants. Scientists weren't even sure if moon soil could sustain plants at all. That's what makes the recent study using actual moon regolith brought back by astronauts so groundbreaking.
This study from the University of Florida tested the growth of plants in 3 different soils collected from Apollo 11, 12, and 17.
A half century ago, astronauts landed on different parts of the moon where they collected moon regolith. For example, Apollo 11 landed and explored a spot where the dirt was more space-weathered.
I was strolling on the moon one day.
The scientists took this moon soil, which was sealed for decades at Johnson Space Center, placed Arabidopsis thaliana seeds in tiny growth wells filled with less than 1 gram of Apollo moon soil, nutrients, and water, and waited.
2 days later, they found that all of these Arabidopsis plants was sprouting. With time, as the plants grow more and more, the plants are more stunted. The leaves are smaller, and there's this reddish pigmentation. And they looked at the RNA profile of these cells by gene expression. They found that those also showed a signature of stress. And so 1, yes, the plants can grow in the regolith, and 2, the regolith does cause some stress in the plant.
Not surprisingly, the plants grown in the older, more space-weathered Apollo 11 regolith were the most stressed.
So those soils then caused more toxicity on the plant, those visible signs of stress.
Further study will be needed to determine why exactly that's the case, or whether introducing microbes into the soil, or growing more drought-resistant plants, or plants with higher nutritional content would work. But one thing astronauts have figured out is the water and sunlight situation in space.
Starting from the Mir space station, the space shuttle years, the International Space Station, we have managed to grow plants in space. What you're seeing here is the veggie unit, the advanced plant habitat on the International Space Station.
Today I'm going to show you how we water the garden here in space.
Watering a plant, which we can do so easily on the surface of the Earth, is much more challenging in space. On Earth, you have rain comes down. Gravity then makes the water flow into the ground. The International Space Station has an environment of microgravity.
We have to use a bag with water in it and a syringe.
You don't want to water too much because you don't want that water to choke the plants from accessing the oxygen that it needs for respiration.
On the moon, you have 1/6 the gravity you have on Earth, so that's more gravity helping you than on the ISS. But the sunlight is trickier on the lunar surface, with 2 weeks of darkness followed by 2 weeks of light due to the moon's rotation.
We're not getting those 12 hours of daylight and 12 hours of night. So we have to create that artificially, and we can do that with LED lights, which can give you very specific wavelengths of light, and you can mix them to make white light so it looks like sunlight.
Just a 3-day trip away, the moon is a small step that will lead to the giant leap to Mars, which involves a very long journey. So there are several reasons why growing our own food in space is key.
Currently on the International Space Station, we have a lot of packaged foods, which are very useful. But just as you can imagine in your own pantry, no matter how carefully and how well we preserve it and package it, eventually the nutritional components degrade. If for some reason, your supplies haven't come on time, you have a plan B.
Anyone who's seen the movie The Martian would agree.
The fertilizer that he uses in the movie may not be the fertilizer that we will use. While you can use astronaut poop, it may not be the most controlled fashion.
NASA prefers powdered fertilizer that can be reconstituted with water. So what will a permanent moon habitat with self-sustaining plant food sources look like years from now?
There are some components that I can tell you that will very likely be a part of these habitats that will help us do sustained stays on the surface of the moon and then in future for Mars. One of them is the fact that we're not going to be growing plants in large farms like we do on Earth. We have to have these controlled environments where we're going to grow them. It's funny to say, but space is limiting in space. We have to make every square inch of space that we use to grow plants count.
One point of reference are the habitats on the South Pole, where researchers currently spend months in bubbles that protect them from the harsh environment outside.
What's interesting is that these folk love hanging out and spending time in the greenhouse. One cannot underestimate the value of having that greenery around you as you venture far away from the surface of the Earth. We will use probably a combination of hydroponics as well as using lunar regolith. Once we have figured out with research how to mitigate the toxic effects, we will live off the land and utilize the soil-like material on the surface of the moon to help us grow plants the way we grow them on Earth. This idea of this one small step then can lead to this giant leap for humankind. My personal hope is that Artemis will be to this and future generations what Apollo was in the 50s, 60s, and 70s in terms of getting the younger folk excited about all the tools, the capabilities, all of the skills that we're going to need to thrive in these environments as our next leap into exploration.